Welcome back to the Historic Mathematics Academy, an inclusive organization founded on truth, where curiosity and engagement connect philosophically to encourage lifelong learning. As always, we're glad you're here. We hope you'll enjoy today's quadratic review lessons and practice quiz with our wisest teachers, Socrates, Plato and Aristotle.
Hello again, I'm Aristotle. Let's review what we've learned together about quadratics. Quadratic equations, when graphed, are parabolic curves. Quadratic relations relate the variables x and y. Quad refers to a square, or a variable raised to the power of 2. The solutions to quadratic equations are where their parabolic curves cross, or intersect, the x-axis where the y-axis value is always equal to 0. This is why the solutions of quadratic relations are referred to as the x-intercepts, or the roots, and sometimes these solutions are called zeros. Depending on where the parabolic curve lies on the Cartesian plane relative to the x-axis, you can have 2, 1, or even 0 solutions. Quadratic relations mathematically describe changes in area and in acceleration in our world. This is why the units of area and acceleration are squared, such as in the unit for area, square miles, or in the unit for acceleration, meters per second squared. During our second lesson together, we literally thought of quadratics by thinking about squares. The length and width of the square represented by the variable x was used to calculate the area of the square, represented by the variable y. We made the connection that the equation for area was actually a quadratic relation, shown in factored form, which when you multiplied together, became the classic quadratic equation y equals x squared. A quadratic in standard form. We then visualized another square, having the dimensions x plus 1. And when we multiplied the length and width, it again created another quadratic equation in factored form. We then continued to multiply the parentheses together to expand the right side of this equation, to change this quadratic again into standard form. I hope you've found this review lesson helpful. Now I would like for you to review what you learned from my teacher, Plato.
Greetings. My name is Plato. I would like to help you to review what we learned together in our past 2 lessons. We started with understanding how to describe characteristics of parabolic curves, which are quadratic equations. We reviewed this graph, where the top point of the curve is called the vertex of the quadratic. Vertices are always the maximum or minimum values of a quadratic relation. The point where the curve crosses the y-axis is of course the y-intercept. And the 2 points where the parabolic curve crosses the x-axis are the x-intercepts, and they are the solutions to this quadratic equation. We then considered a different quadratic relation, modeling the path of a ball kicked in the air over time, and answered these questions together. During our second lesson I helped you to understand how to interpret parabolic curves on a graph of a rocket launched from the ground, where the y-axis represents height in meters, and the x-axis represents time in seconds. We identified that the top point of the curve has the coordinate 5 and 500, and I asked you these 6 questions about what this parabolic curve is telling us. Now, you should feel more comfortable describing and interpreting parabolic curves on a graph. I wish you good luck on your practice quiz. Keep up your hard work. Now, I'd like for you to continue your quadratics review with my teacher Socrates.
Hello again, my name is Socrates. During our first lesson, I taught you 2 different ways to write and describe quadratics algebraically. The standard form of a quadratic equation, where we identified the coefficients in front of each term of the variable x, represented by the letters a, b, and c. The quadratic equation seen here, at the top, that is in standard form, has the a coefficient of positive 1, the b coefficient of positive 1, and the c coefficient of negative 2. We also made the important connection between the y-intercept on the graph and the coefficient c from the equation. That they are identical, and whenever a quadratic equation is written in standard form, its coefficient c is always the y-intercept. Next, we learned the factored form of quadratic equations. Factored form reveals the x-intercepts, or the solutions to the quadratic equation when you set y equal to 0. You can see from the graph of this quadratic equation's parabolic curve that the x-intercepts are -2 and -1 when y is 0. We then reviewed an example to understand how to change a quadratic equation in standard form to factored form. Noticing that in standard form, the c coefficient is identical to the graph's y-intercept, we changed this equation to the factored form, using the product sum rule. Once in factored form, we revealed the x-intercepts by setting y equal to 0. Next, during our second lesson, I helped you to master changing quadratics from factored form to standard form, and from standard form to factored form. We began with this quadratic equation in factored form, and discovered that moving from factored form to standard form can be achieved simply by expanding through multiplication and addition. I showed you this first, because it will remind you of the process to change from standard form back into factored form. Revealing the product sum rule, seen here. I then helped you make the connection to y positive 2 is green and y negative 1 is black, because they are the very same two numbers that are in the parentheses of the original factored form equation at the top. Once you have these two numbers, you can change your quadratic equation from a standard form to factored form. This is factoring, the opposite of expanding. I've enjoyed my review of our lessons with you. Now, I would like for you to review with my greatest student, Plato. I wish you good luck on your practice quiz.
Hello again. Let's review what we learned in our past 2 lessons from Socrates by going over the quadratic problems we solved together. First, we solved this quadratic by finding the x-intercepts of this equation in factored form. Remember, factored form reveals the x-intercepts by setting y equal to 0. Next, we determined what is the y-intercept of this quadratic relation is knowing that in standard form, the c coefficient term, highlighted in blue, is always the y-intercept of the quadratic. Next, we looked at this quadratic equation at the top of the page and worked to solve for x, or to find the x-intercepts, using the product sum rule, asking the question, what two numbers both add to the b coefficient value of +1, and both multiply to equal the c coefficient's value of -2. Can you think of two numbers that satisfy these two equations? The numbers +2 and -1 work for both equations. Now, we simply substitute these two numbers into our factored form quadratic format seen here, where our chosen numbers are in red font. And now that we're in factored form, we can solve for x by setting y equal to 0 on the left side of the equation and solved for x. Next, during our second lesson together, we solved this quadratic by finding its x-intercept by first changing it to factored form. Again, with the product sum rule, we found two numbers that both add to +5 and multiply to -6. Then we inserted these numbers into our factored form format seen here, and revealed the x-intercepts by setting y equal to 0. And solved for x. I had a great time reviewing the math skills we developed together. I wish you good luck on your practice quiz, and I hope to see you back here soon.
Your practice quiz is about to begin. Please do your best, and good luck. Let's begin. Question 1. True or false? This is an example of a quadratic in factored form. Y equals x squared plus x minus 2. Please provide your answer. Question 2. True or false? the solutions to a quadratic are its x-intercepts. Please provide your answer. Question 3. True or false? This is an example of a quadratic in standard form. Y equals x plus 2 times x minus 5. Question 4. What is the y-intercept of this quadratic? Y equals x squared plus x. Please provide your answer. Question 5. What is the minimum value of this quadratic? Please provide your answer. Question 6. A. What is the y-intercept of this quadratic? Next. Please provide your answer. B. What are the coordinates of the vertex? Please provide your answer. Question 7. What are the x-intercepts of this quadratic? Please provide your answer. Question 8. What are the x-intercepts of this quadratic? Y equals x plus 8 times x minus 4. Please provide your answer. Question 9. What are the x-intercepts of this quadratic? Y equals x squared plus 5x minus 6. Please provide your answer. Question 10. What is the factored form of this standard form quadratic equation? Y equals x squared plus 7x minus 8. Please provide your answer. Question 11. What is the standard form of this factored form quadratic equation? Y equals x plus 4 times x minus 3. Please provide your answer. Congratulations! You have finished the practice quiz. Well done. We hope you enjoyed your stay at our Historic Mathematics Academy. Thank you for your curiosity and for engaging with our math teachers. We appreciate your time. Please remember to stay safe, to get your rest and to continue your lifelong learning. Bye for now.